This chapter will cover the core graphics component of Hoops Visualize. And these are the concepts we'll get through, the various components of core graphics, the object database, traverser, and pipeline. We'll talk about how you need to create a world object, how to set a license key, and then we'll have an exercise at the end. Okay. We've already reviewed that this is a retain mode graphics system, but I want to focus on that a bit more. It's essentially a graphics database. When you are making calls to the Hoops Visualize API, the primary thing that you're doing is using the core graphics API to build up an in-main system memory hierarchy of graphical information. So it's a database, it really is. And of course, with any kind of database, you're going to create content in it, query it, edit it, delete it, move things around. Okay. We support a variety of data encapsulation, instancing, attribute inheritance capabilities, and they're all kind of parts of object-oriented principles. So this kind of lays out the visual look of the three components. Okay. In the graphical object database, we are building up a scene graph shown at the bottom there, and the scene graph in a 3D graphics system is really a hierarchy of nodes. And that lends itself to a child inheriting its parents' opinion of attributes, or modeling matrices concatenating down through the nodes, of course. Facilitates things like animations and whatnot. And in Visualize, these nodes are called segments. So you'll hear this a lot more. A lot of operations and class names and methods have the word segment in them. Okay. Because this is a retain mode scene graph, the order of insertion of entities into any segment is not important. You declare the scene graph. It's what we call a declarative API. And then once you're done declaring the contents of the scene graph, you make calls to instruct Visualize to redraw. So you make a change, then you tell Visualize to redraw, et cetera, et cetera. And we'll get into actual examples of that, of course. The object traverser is an internal algorithm that walks that scene graph, looks at the attributes, determines how to set up things to be ready to draw them with the appropriate attribute settings to the interface that you've specified. It could be to the screen with Direct3D or OpenGL, or it could be out to a hard copy device, it could be out to a file format, etc. And Hoops Visualize will break down information through this something called successive decomposition technique, or the structured device interface, through to the output device. The method that you call to tell Hoops to actually traverse the scene graph and update to the display, whether it's on screen or file or hard copy, is update. It's an intelligent update where we'll look at what's changed from the previous update and figure out the minimum amount of work that we need to do to make sure that the picture that you're seeing matches the latest state of the scene graph that you've edited or modified. There are several different classes that support the update method, so we'll get into more code specifics on that later. But generally, that's the concept of if you made a change and you want to see the results of that become live, you will have to call update, or some other internal code may have to call update. I mentioned this a little bit 2 slides ago. So when we update the scene internally, we're telling Hoops Visualize to figure out how to get what's in that scene graph out to the device. Well, what if it's a raster image device, or what if it's a 2D PDF or a Windows clipboard or print device? Some of those things are not 3D interfaces. So what our internal Hoops Visualize device interface can do is break it down and decompose it from 3D to 2D, or also called DC, or device coordinates. But we can also do full software rendering pipeline software Z-buffer, but also software lighting. So we have algorithms to break everything down to whatever level we need to get that picture out. So that ensures that regardless of the platform or the device interface, you'll get the same picture. Now, performance might be different. Obviously, if you're on a super high-end ATI or NVIDIA graphics card on your visual display, it can draw 1 billion triangles a second, versus if you're going out to a 2D PDF document, or you're going out to a Windows print preview or hard copy device. But we'll take advantage of the interface's API as much as we can. So before we can get started actually having Visualize draw something on the screen and get our basic application started, we need to create the world object. Okay, and this is the class diagram for it, class documentation. And when we initialize the world object, we need to include our license key. So the constructor for our world object accepts the license key. When you generate the license key from the developer zone license key generation page, you're given a hoops_license.h file, and there's a placeholder license hoopslicense.h file in this subdirectory of your installation. And once you generate your license key, you can just edit that placeholder file and then set things up correctly. Okay. Another little side note here, the classes of Visualize are members of the HPS namespace. So in your source code files, typically then to take advantage of that, you would declare using namespace HPS. Okay. So we'll go through an exercise here where we'll give a tour of the sandbox, one of the sandbox applications. I'll ask you guys we'll generate a license key at the developer zone, set that license key at the appropriate location in our sandbox source code, and then we'll just load in a sample file.